Good evening. Good evening, Pa.
Sir,
Hariharan. Good evening. Hariharan. Could you hear my voice, Hariharan? Hariharan. So, shall we start? Last class, what we have discussed, Ma? Hmm? Could you recall? What are the things we have discussed? What is system, surrounding? Hariharan. Could you hear my voice? Hariharan. Hariharan. Hariharan Ganesan. Murali.
sir,
What we discussed in the last class? The thermodynamics.
sir, isoporic, adiabatic, isobaric, all types of processes.
Types of process, right?
Yes, sir.
Have we discussed about the work? No, not it.
Yes, sir. Yes, sir. First law of
Work.
thermodynamics.
First law of thermodynamics we have completed.
Yes, sir.
Okay. So what is the first law of thermodynamics?
Sir, energy can neither be created nor destroyed, but energy form can be conducted.
Right. So when you are coming to the first law of thermodynamics, could you see that? No, what I am writing.
Yes, sir.
So the first law of thermodynamics, it's a conservation of energy. It gives so energy can neither created nor be destroyed. So it concentrate about the energy. So the mathematical form of the first law of thermodynamics, that would be. So what is the mathematical form of first law of thermodynamics?
Delta U is equal to Q plus W.
Delta E is equal to
Q
Q
plus
plus W. So we know that many process, isothermal process, isochoric process, adiabatic process, isobaric process. First, you should know what is isothermic process. Isothermic process means the temperature remains same or temperature is constant. Correct? So isothermal process means the temperature is constant. Temperature is constant. And then isochoric. So choric means volume is constant. And then isobaric. What is the constant?
pressure.
Pressure is constant. And then adiabatic. What is adiabatic? So the temperature cannot exceed. Okay. So temperature is not lost or not gained. So the system would be at same temperature. So temperature cannot change.
So adiabatic and isolated system are the same.
What?
Adiabatic and isolated system are the same.
Same. Temperature cannot, so the adiabatic or isolated are one and the same. So the temperature cannot exchange with the surrounding. So now we got the first law of thermodynamics. When isothermal process, temperature is constant. So the first law of thermodynamics become, what would be? So temperature constant mean delta E become, so the energy of the system is equal to heat given to the system plus work done by the system. That is Q plus W. Okay. So we know that the temperature is not given. Okay. So temperature is constant. So automatically delta E becomes 0. Then what happened? 0 plus Q plus W. That's equal to Q is equal to minus W. The first law of thermodynamics can be changed. And then for isochoric process, the volume is constant. That means what? System does not do any work. When the volume is 0, volume is constant means, so it's a, so delta V become 0. Delta V becomes 0 means work is 0. வால்யூம்ல ஒரு வால்யூமே எதுவுமே இல்லைன்னா ஒர்க் என்ன பண்ண முடியும்? ஒன்றும் பண்ண முடியாது. Then delta E become Q. That means the heat given to the system at constant volume change the internal energy. So this is the heat given to the system. It can change the internal energy. For the adiabatic process, the heat cannot exchange. Q is equal to 0. Then delta E become work. Am I right? That means
Yes,
work
sir.
done on the system equal to change in the internal energy. That's what we are getting. Suppose if the adiabatic process means same way. So isobaric process la pressure is constant. For the, sorry, நான் adiabatic சொல்லிட்டு isobaric போட்ட பாருங்க. For the isobaric process, the pressure is constant. When the pressure is constant means work done by the system is based upon the volume of the system. So volume delta V is not changed. So pressure is constant. Then delta E become Q plus W. Okay. Now when the isochoric process, so you have two types. One is gas expansion, another one is gas contraction. Okay. One expansion, இன்னொன்னு வந்து compression. ரெண்டு இருக்கு. When the work done on the system, done by the system, so it can be work done by the system. That means when the gas expanded at constant pressure, the work done by the system, it gives minus P delta V. That means W is equal to minus, because delta V is equal to volume 2 to volume 1. Yeah. We are changing, we are expanding. So the initial volume, final volume can be changed definitely. So the delta E become Q minus P delta V. Okay. If the gas expanded in the vacuum, W becomes 0, pressure becomes 0. So the work done, what work done is 0. Okay. So for the adiabatic process, Q is equal to 0, then delta E is equal to W. So work done on the system is equal to change in the internal energy. So first law of thermodynamics tells energy can neither be created nor destroyed, but one form of energy you can transform into another form of energy. So it concern about only about the energy. So the mathematical form of first law of thermodynamics, that is equal to internal energy is equal to heat content and the work done on the system. Okay, work of the system. So it is a mathematical form. When various process apply to your first law of thermodynamics, So when you are applying the isothermal process means temperature is constant. So the internal energy becomes 0. Then heat content or heat given to the system is equal to minus work. That means work done on the system. Okay. Then isochoric process means volume remain constant. When the volume is constant, then work will not be done. Because when your gas expanding or compressing, volume will change. When the volume changes, your work will be done or by the system happens. When the volume is 0, where volume 0 means it constant. When the volume is constant, means you cannot have any work on that. Then the internal energy is equal to how much of the heat supplied to the system. It is right. For the isobaric process, so you have the constant pressure, then when the process gas expanded against the constant pressure, one work done by the system, another one if the gas expand in the vacuum. So we have two things. So one you will get like this, another one you will get like this. For the adiabatic process, temperature is not exchanging. Okay. Then Q is equal to 0. Heat supplied to the system is 0. Then delta E is equal to delta W. So this is the first law of thermodynamics. So first, we should understand the pressure volume work. இது வந்து அன்னைக்கு அந்த தெர்மோடைனமிக் பவர் பாயிண்ட்ல பாத்தீங்க இல்லையா? Do you remember பா? தெர்மோடைனமிக் பவர் பாயிண்ட் பார்த்தது ஞாபகம் இருக்கா? All of you? Just a minute. I will show that power. Again, we will see that. Then you can understand very easily. Do you remember that PowerPoint? So what is isothermal process? Can anyone explain about that? What is isothermal process? Just give an idea about that. What is isothermal process?
The process where temperature of the system becomes constant.
Temperature of the system become
Constant.
temperature of the system remain constant. Just we have to go through that and then we will go further. This is what the day we have seen. Kinetic energy system surrounding. Yes. So this is what called pressure volume work. Here you have the sodium metal. So whatever it's shown here, no, it's a sodium metal. So this is the sodium metal. When you put it in the water, what will happen? It release hydrogen gas. When the hydrogen gas release means initially you have the volume like this. So this you have taken a cylindrical fitted and frictionless weightless piston you have. So now what happened when the reaction is happening, hydrogen gas is released. When the gas release means the volume get expanded, right? Am I right or not? So all of
Yes, sir.
you can see the picture. You have the water and then you put the sodium. When the water and sodiums are reacted, when the work is done, okay, between when the chemical process are taking place between the water and sodium, it releases the gas. When the gas is expanded, so the piston goes from here to here. So what happened? Initially you have this much volume from here to here. Now it has additionally. So what happened? Because of that, it given some amount of the volume is changed, right? So the work done is equal to minus P into delta V. So you are not applying any pressure, right? Because of the chemical process, the volume get increases. So it gives the W is equal to P delta V. And then it liberates a heat energy. That's why they said minus 368.6 kilojoule per mole. Okay. Now, a volume of gas cylinder and V is V. And the pressure acting on the piston is P, which is slightly lesser than the internal pressure of the gas. Due to the internal pressure, the gas expands and the piston moves from small distance from here to here. Now, we know that pressure is equal to force by area. Okay. So then force equal to pressure into area. Am I right? Am I right? So what we are calling the force is we are calling is work. So work done by the gas. Here, what is the gas? Gas we are considering as a system. Okay, that's equal to force into distance. Force into distance. Distance. So now we got small amount of work which is done by at constant pressure. Okay, and then dV. Okay, so now what we had decided, pressure is equal to force by area. Now force equal to pressure into area. So work done by the system. System means what? Gas. That's equal to force into distance. So force is equal to pressure into area. Then distance is small distance. Distance what we are telling. So area into distance, it will give how much amount of volume, correct? So pressure into this to give dV. Okay, so small amount of work which is done by, that's equal to minus P into dV. So negative sign is work done. So negative indicate done by the system. Now, so the volume is changes, no? That's why we have to calculate W is equal to minus P V1 to V2 into dV. So when you are integrating, it become dV become V. So you have the two limits. Then V2 minus V1, that's equal to P delta V. So W is equal to P delta V. This is how we are calculating the work. Okay. Is it okay? So when the system, the volume is changed, Noma, gas, when you are compressing or expanding, the volume of the gas will be changed. Say yes or no?
Yes, sir.
So suppose if you are applying external pressure, so the gas, what will happen inside the cylinder? சொல்லுங்கப்பா. If you are applying pressure, முதல்ல சோடியமும் வாட்டரும் இருந்தது, அதுல ஹைட்ரஜன் கேஸ் வெளியே வருது, வெளியே வரும்போது கேஸ் வந்து எக்ஸ்பேண்ட் ஆகுது, ஸோ வால்யூம் சேஞ்ச் ஆகுது. சப்போஸ் அப்போ வந்து உள்ள ப்ரெஷர் இல்ல, வெளியே நீங்க ப்ரெஷர் அப்ளை பண்ணல, உள்ள இருக்க ப்ரெஷர்னால பிஸ்டன் மூவ் ஆகுது. நவ் இஃப் யூ ஆர் அப்ளையிங் அவுட்டர் சைட் ப்ரெஷர், அப்ப என்ன ஆகும்? கேஸ்
Compressor.
Yes, it's exactly compress it. Correct? So the gas will contract. When the gas is contracted, mean work will done by the system or done on the system.
Work is done on the system, sir.
So work will done on the system by the surrounding. Okay. So we can apply the same formula, but we have to use the sign will be different. That's all. Okay. Now we can write if the W can be, you can write P delta V. Okay. Epo when V2 is greater than V1. Epo V2 is greater than V1. Epo nadakum expansion of gas nadakumoda volume of 2, second volume become more than the first volume. Correct? Am I right or not?
Yes, sir.
So this will be the work is done by the system. So when you are solving the problem, so when the W value you are getting minus, you have to say whether work done by the system or done on the system. Okay, that's why you keep it in mind. So done by the system is negative. Done on the system is positive. Okay, இத மறக்கவே கூடாது நம்ம. Done on the system is positive, done by the system is negative. When the W is equal to P delta V, எப்போ கிடைக்கும்? When V1 is greater than V2. Correct? So when it will happen? When the contraction of the gas, contraction or compression of the, then what is this? Work done on the system. Okay, is it clear, ma? Is it clear or not?
Yes, sir.
So this is the application of your first law of thermodynamics. Now we know that. So what is the unit for the work? We told that work is equal to force into distance. Force means Newton, distance means meter. So it can be Newton meter or it can be joule. So the unit of work are same as of energy. When you are calculating energy in the terms of joules, you have to express in terms of joules, or you have to express in terms of Hertz. Hertz means 1 Newton meter. Okay. So the work is equal to force into distance. Force means mass into acceleration. Okay. So mass means kilogram. Acceleration means meter per second square. And then distance or meter. So when you are calculating the unit of work become X or joule. Okay. Or otherwise kilogram meter square per second. So how you can say kilogram Newton square works equal to force into distance. So it gives force is a Newton and meter. It gives Newton meter. It become 1 joule. Or otherwise, the force equal to mass into acceleration. How much acceleration you are given into how much distance. So it gives the mass will be kilogram, acceleration will be meter per second square, and then distance will be meter. So it gives kilogram meter square per second square. Okay, this is what we have. We can give the unit of the gas. And then if the work is done in the isothermal expansion of ideal gas. So for the ideal gas, what is the equation for ideal gas? You know that when the van der Waals equation become PV is equal to nRT, and then P plus A by V squared into V minus B is equal to RT. Do you remember these two equations? So this equation will be ideal gas equation. When the van der Waals coming, he given the pressure and volume changes for the ideal gas equation, then this will be for the real gas equation. So now what we are thinking, we are concentrating if the work done in the isothermal reversible expansion of an ideal gas. So now we have to calculate, no, when you are calculating what is the equation that you have to. So what we have seen, dW is equal to minus P dV, correct? So what we are saying, when the initial volume, so what is the condition? You tell me. Isothermal reversible expansion of an ideal gas. So we know that W is equal to P into minus work done on done in, okay, dV V1 to V2. So you know that PV is equal to nRT for the ideal gas equation. P is equal to nRT by V. You substitute here. So when you are substituting, minus P nRT by V into V1 to V2 by dV. Here you have the V, here you have the V. These three are constant. Then you can separate minus nRT integral symbol of V1 to V2 dV by V. We know that when you have the dV by V, when you're integrating, it become ln V. Okay, so minus nRT ln V V2 to V1. So when you are substituting, minus nRT ln V2 minus ln V1, then it become minus nRT ln V2 by V1. So please remember, log A minus log B, you can write log A by B, or log A plus log B, that's equal to log AB. This is the mathematical formula. Okay. So what the equation you are arrived? Minus nRT ln V2 by V1. So the natural logarithm, you have to convert it into log. So minus 2.303 into n mole into R into T of log V2 by V1. So otherwise minus 2.303 nRT log P2 by V1, that is equal to work done in the isothermal reversible expansion of ideal gas. What is N? N is the number of moles, R is the gas constant, T is the temperature, the final volume and initial volume. When you are substituting, you will get the volume. So here for the isothermal process, temperature is constant. Okay. So when you are changing volume is constant means now you have to change. So when your volume is constant means what you will get? So V is equal to, you tell me ma, when the volume is constant, so now the pressure is constant, sorry, temperature is constant. So the equation you can change, instead of PV is equal to nRT, or otherwise V is equal to nRT by P also you can put, no, when the pressure change. So if you are getting change in the pressure, it gives the equation differently. What type of equation you will get? Suppose இங்க V க்கு பதிலு இந்த இடத்துல dV இருக்கு இல்லையா, W is equal to minus V P1 to P2 into dP ன்னு வருது. ஏன்னா pressure change ஆகும். pressure change ஆச்சுன்னு சொன்னா the equation எப்படி change ஆகும்? W is equal to minus 2.3 nRT log P2 P1 by P2. ஏன்னா pressure 1 இருக்கும்போது volume 1 இருக்கும், pressure 2 இருக்கும்போது volume 2 இருக்கும். அப்ப என்ன ஆகுனா pressure is indirectly proportional to your volume. Okay, is it okay? Okay, so the equation become like this. So what is the minus sign indicate? Minus sign indicate work of expression, indicate expansion of gas or work done by the gas, otherwise system. Okay, இதுதான் இதுல வந்து கிடைக்கிற equation. Next,
Doubt, sir.
yes, ma.
Sir, on the V1, V2 by V1 க்கும் P1 by P2 க்கும் என்ன சார் டிஃபரன்ஸ் சொல்லுங்க?
So இங்க என்ன சொல்றோம்னா ஐசோதெர்மல் ப்ராசஸ் சொல்றோம், டெம்பரேச்சர் கான்ஸ்டன்டா வச்சுக்கும் போது வால்யூம் சேஞ்ச் ஆகுறத சொல்றோம். ஓகேவா? So same thing you can apply for the pressure also. ஓகேவா? So pressure change ஆகும்போது when the volume you are putting constant, okay, PV is equal to nRT ன்னு gas equation ல we are telling P is equal to nRT by V. Suppose V ni fixed ஆ வச்சிட்டு nRT by P வந்ததுன்னா then you can put, instead of V you can put nRT by P, no?
Yes, sir.
So when you are putting nRT by P, that equation become log P1 by P2. That's all.
Okay, sir.
P1 V1. Okay, pressure 1 V1 is equal to nRT constant. Okay, pressure 2 V2 become nRT. No doubt, correct? When you equate these two equation, P1 V1 is equal to P2 V2, right?
Yes, sir.
Then V2 by V1 become P1 by P2. Is it right
Yes.
or not? Is it right or not? Could you understand how
Yes, sir.
I put it this? Now is it okay?
Yes, sir. Okay, sir.
That's why, because நீங்க வந்து வால்யூம் தான் சேஞ்சஸ் கொடுக்கணும்னு அவசியம் இல்ல, பிரஷர் சேஞ்சஸ் கொடுத்தா கூட நம்ம கண்டுபிடிச்சலாம். ஏன்னா ஒரு பிரஷர்ல இருந்து இன்னொரு பிரஷருக்கு மாறும்போது ஒரு வால்யூம் சேஞ்ச் ஆகுது இல்லையா?
Yes, sir.
சப்போஸ் இதுவே பாசிட்டிவா இருந்தா என்ன இருக்குன்னா P2 மேல வரும், P1 கீழே வரும். இங்க V1 மேல வரும், V2 கீழே வரும். இது எக்ஸ்பான்ஷன்றதுனால V2 மேல வந்திருக்கு. கம்ப்ரஷனா இருந்தா V1 மேல வரும், V2 கீழே வரும். புரியுதாமா எல்லாருக்குமே?
Okay, sir. Understood, sir.
ஒரு பிஸ்டன்ல போட்டு உள்ள வந்து கெமிக்கல் ப்ராசஸ் நடக்குது. கெமிக்கல் ப்ராசஸ்னால கேஸ் வந்து எக்ஸ்பேண்ட் ஆகுது. அப்ப என்ன ஆகுது? V1 ல இருந்து V2 சேஞ்ச் ஆகுது. So the V2 is more than the P1. Suppose நீங்க வெளியே இருந்து pressure apply பண்ணி you are compressing சொன்னா இனிஷியலா இருந்த வால்யூம் விட அடுத்த வால்யூம் குறையுது. அதுதான் we are written here. V1 வந்து compress பண்ணும்போது P delta V மாறுது. இங்க பாருங்க V1 V2 V1 is greater than V2. But இங்க expansion நடக்கும்போது V2 is greater than V1. So what we are doing here, isothermal reversible expansion. That's why we are written minus. அப்போ isothermal contraction நடந்தா என்ன வந்திருக்கும்? சும்மா ஒரு பேச்சுக்கு plus 2.303 RT log V1 by V2. That's all. அப்ப இந்த equation எப்படி இருக்கும்? W is equal to 2.303 RT log P2 by P1. Is it okay? Clear?
Yes, sir.
Very good. Now, so we are going to see about the next one, that is free expansion. So what is called free expansion? Expansion of gas in the vacuum is known as free expansion. Okay. So free expansion means expanding gas, expansion of gas in vacuum is called free expansion. So the external pressure external becomes 0. So no work is done during the free expansion. So work is W is 0. So whether the process is reversible or reversible, the P external is 0, then delta E is equal to Q plus W. So now we tell the W is 0, then delta E become based on the Q, correct? So no work is done during the free expansion of ideal gas. So the P external is 0. First one, for the isothermal process, when the isothermal process, the temperature is constant, correct? When the temperature constant, Q is equal to minus W. Am I right? So W is equal to pressure externally you are applying, then V2 to V1. So that equation will get. Suppose for the adiabatic process, Q is equal to 0, then delta E is equal to work done adiabatically. Then the third one, isothermal reversible. Reversible இருக்கும்போது என்ன ஆகும்னா Q is equal to minus W, that's equal to nRT log 2.303 nRT log V2 by V1. This is what we will get it. Okay, now the first law of thermodynamics which introduced a term is called enthalpy. So enthalpy is nothing but it's a change of energy. You are during the chemical reaction, நம்ம என்ன சொல்றோம், ஒரு ரியாக்ஷன்ல வந்து எனர்ஜி அப்சார்ப் ஆகுதுன்னு சொல்றோம், ஒரு ரியாக்ஷன்ல வந்து எனர்ஜி வந்து ரிலீஸ் ஆகுதுன்னு சொல்றோம். If you want to calculate amount of energy, how much it போயிருக்குன்னு கண்டுபிடிக்கணும்னா that you can calculate by using the enthalpy. So enthalpy is a state function which you can calculate it for the chemical reaction. So the enthalpy of the system is equal to, you can add the internal energy and the work done on the system. Okay, work of the system plus internal energy, it gives the enthalpy. So enthalpy is a state function because it changes from one point to other point. That's why we are telling it is a state function. So you can calculate from the initial to final or final to initial, you can calculate the enthalpy. But if you are taken heat content, that you cannot calculate. ஓகேவா? இனிஷியல் ஃபைனல் ஹீட் கண்டென்ட் கால்குலேட் பண்ண முடியாது. ஸோ என்தால்பி is equal to enthalpy H is equal to, so the sum of internal energy and then pressure volume. So what are the state function? What are the based on the state function? Enthalpy is a state function, internal energy is a state function, but volume is a state function. So H1 is equal to E1 plus P1 V1. H2 is equal to E2 plus P2. When you are subtracting H22 minus H1, then E2 minus E1 plus P into V2 minus V1 you get. So this we are changing delta H. This is delta E plus P delta V. Some of the case the E can be replaced as U. U and E are same. E is the internal energy, U is the internal energy. Both are same. So delta H is equal to delta E plus P delta V. This is the mathematical formula for calculating the enthalpy. So delta is change in the internal energy. Delta P delta V is known as work done. So otherwise delta H is equal to delta E plus change in work. So other than P delta V சொல்றாங்க. Okay. So இப்போ most of the chemical reactions which will be occur in atmosphere pressure in the open vessel. That means what? The pressure of the system become how many atmosphere? Open systemத்துல இருந்தா என்ன pressure இருக்கும்? Pressure is equal to how many atmosphere? Tell me pa. தம்பிகளா, இப்போ ஓபன் சிஸ்டம் நம்ம வந்து ஒரு பாத்திரத்துல எடுத்து தண்ணி காய்ச்சுறோம். அப்போ அதோட பிரஷர் என்னவா இருக்கும்? So many chemical reaction which occur at constant pressure. அது என்ன pressure? Constant pressure. Please open your mouth and tell me.
Sir,
நம்ம
question
தண்ணி yes. இப்போ we are taking a pot of water and heating. What would be the pressure of the system?
சார் அந்த வேல்யூ சொல்லுமா இல்ல என்ன சார் சொல்லுங்க?
ஆமா, அந்த வேல்யூ தான் சொல்லுங்க. இப்போ ஒரு ஓபன் வெசல்ல எதை ஹீட் பண்றீங்கப்பா, அதோட பிரஷர் என்னவா இருக்கும்? That's equal to constant pressure சொன்னா என்னது?
சார் 2.3 அதுவா சார்?
2.3
அதுவா?
No ma. That is 1 atmosphere. That is constant pressure ma. அதாவது whatever we are taken, ஓகேவா, that is 1 atmosphere. ஓகே. இப்போ ஓபன் சிஸ்டத்துல வச்சிருக்கோம், நம்ம ஒரு பாட்ல தண்ணி எடுத்து சூடு பண்ண போறோம்னா அந்த பிரஷர் என்னவா இருக்கும்? 1 atmosphere. 1 atmosphere விட கம்மியா இருந்தாலோ இல்ல 1 atmosphereக்கு மேல போனாதான் பிரஷர் சேஞ்ச் ஆகுது. புரிஞ்சுதா? 760 millimeter per mercury mmHg அப்படின்னு படிச்சிருக்கீங்களா? 760 mmHg bar pressure அப்படின்னு படிச்சிருக்கீங்களா? சோ பிரஷர் அப்படின்னு சொன்னோம்னா இப்ப நார்மலா இருக்கும் போது என்னன்னா, இப்போ ஒரு சொல்யூஷன் பாயில் ஆகுது. எப்போ பாயில் ஆகும்? when the temperature of the system or the vapor pressure of the system which is become equal to the atmospheric pressure, then the solution get boils. That point is known as boiling point. Okay, atmosphere pressure ன்னு சொல்லும்போது நார்மலா என்ன சொல்றோம்? 1 atmosphere pressure. இதுதான் கான்ஸ்டன்ட் வேல்யூ. ஒரு பாத்திரத்தில் தண்ணி எடுத்து சூடு பண்றோம், ஹீட் பண்றோம்னு சொன்னா when the that is called open system, right? We are not closing. When the open system you have, that pressure will become 1 atmosphere. Okay va? Many of the chemical reaction we are conducting at open. Test tube ல பண்றதெல்லாம் open system தான். So அதோட pressure என்னவா இருக்கும்? 1 atmosphere pressure தான். Okay. So we can measure the value of heat. வெளியே கொடுக்குதா இல்ல அப்சர்வ் பண்ணதா, that we can observe. That is known as enthalpy change. புரிஞ்சுதா கண்ணா? எல்லாருக்கும் புரியுதா? ஒண்ணும் இல்லப்பா, ஒரு டெஸ்ட் டியூப்ல வாட்டர் எடுக்கிறீங்க, you are adding sodium. Okay, you are putting the thermometer. First initially you are taken that, you are checking the thermometer, and when these solution reacted, that time you are checking the thermometer. So now the changes can be happen. Okay, well, that changes only we are telling that enthalpy change. Okay, so when the gas, for the gas, first we can calculate for the liquid and solid. When the system is liquid or solid, so solid க்கும் liquid க்கும் delta V becomes 0. Volume இருக்கு. Okay, so W become 0. Then delta H equal to delta E. Correct? உனக்கு வால்யூம் எக்ஸ்பேண்ட் ஆக போறது இல்ல, வால்யூம்ல சேஞ்சஸ் இருக்க போதா? லிக்யூடுக்கும் சாலிடுக்கும் எடுத்தீங்கன்னா வால்யூம்ல சேஞ்சஸ் இருக்க போறது இல்ல. சோ கான்ஸ்டன்ட் பிரஷரா இருக்க போகுது. சோ the pressure in the delta V is to 0, that gives 0. That's why delta H equal to delta E. Whereas for the gas, we know that PV is equal to nRT. We know that there will be volume change for the gas. PV is equal to delta V is equal to, so definitely on the starting material changes for delta N GRT. The G is corresponding to gaseous substance. Okay, when delta H equal to delta E, the enthalpy is equal to delta E plus P delta V. That P delta V என்ன சொல்றோம்? Delta E plus delta NGRT. So what is delta NG? So delta NG is nothing but delta E plus number of product minus reactant into RT. So delta H equal to delta E plus delta NG and RT. Now delta NG is equal to 0. We can apply. When the NG is equal to 0 means what you will get? This will be 0, na? The whole term will be 0. Then the equation become delta H equal to delta E. For as like were solid and liquid. Suppose delta NG is negative. So this become negative. The whole thing become negative. Am I right, ma? Am I right? So when you are going to subtract delta the negative part from the delta E, then automatically delta H is greater, sorry, delta H is lesser than delta E, right? இங்க பாருங்க, you apply delta NG ஓட வேல்யூ 0 இருக்கு, the whole thing 0 ஆயிடுது. அப்ப delta H become delta E. Suppose delta NG வந்து நெகட்டிவா வருது, so negative into positive become negative. Okay, so the negative value are subtracting from delta E, so delta H become less than the delta E. Suppose delta NG is positive, then delta H greater than delta E. Okay, so what is the conclusion? When the delta H is negative, it's a exothermic reaction. When the delta H is positive, it's a endothermic reaction. That means you have to supply energy for this, then you have to subtract the energy from this. So the energy can be released. Here, energy released. Here, you have to energy supply. Are able to understand?
Yes, sir.
Now, we'll calculate one reaction and then go. So you can have the PCl5 gas, which are it decomposed into PCl3 gas and Cl2 gas. You calculate the delta H is greater than delta E or delta H equal to delta E, or delta H is less than delta E. Now you have to predict. So how can you predict? First you have to calculate delta Ng. Delta Ng is number of product divided minus number of reaction. So you have 1 plus 1, 2. 2 minus 1, it become 1. Apo delta Ng become 1. So delta Ng 1 delta H equal to delta E plus delta Ng RT. Now you substitute, then delta H equal to delta E plus RT. Now, so delta H is greater than delta E. Am I right? Correct? Huh? When the delta H positive means the reaction is exothermic or endothermic?
Endothermic, sir.
Endothermic, sir.
What?
Endothermic.
Very good. So now you tell me, you have hydrogen iodide, it decomposes into H2 plus I2. Now you tell me, what is the delta Ng value? Delta Ng value become? இங்க
One,
பாருங்க,
sir.
1, 1, 2, minus 1. That's why 1. அப்ப இதுக்கு? One plus 1 product minus இது எத்தனை? Reactant எத்தனை?
1, sir.
How it is 1 ma? You are taken 2 moles, 2. Then 0. Delta H equal to delta E. That is why you are getting equilibrium cycle. புரியுதா? Is it clear?
Yes, sir. Okay. Yes, sir.
So now you tell me, carbon plus oxygen gives carbon dioxide. Now you tell me delta E plus delta. Sorry, இந்த reaction கொடுக்க கூடாது, ஏன்னா இது ஒரு solid ஒரு liquid. H2 plus O2 gives H2O. So half of the O2. அப்படி இல்லைன்னா 2H2 plus O2, 2H2O2. Now you tell me whether the reaction is endothermic or exothermic, or delta H value greater or delta E value greater. What is the delta Ng value? 2 minus 2 minus
2 plus 1, sir.
then 3, right? Then become minus 1.
Yes, sir.
So delta H equal to delta E plus delta Ng RT. See, at least keep on கூடவாது சொல்லுங்க, சொன்னீங்கன்னா it should register in your mind. Okay, then delta H is greater than or lesser than delta E?
Lesser than delta E.
Then the reaction is? Then the reaction is?
Sir, exothermic.
That's all. Okay, so we can find out whether the reaction is exothermic or endothermic based on this. Okay, now another question. So how you know that here the value delta H become positive or negative? So heat content of the product minus heat content of the reactant, which gives the delta H value. So another one more point I would like to add, delta H equal to heat content of product minus heat content of reactant. So HP minus HR. If it is exothermic, which should be more? If it is exothermic, HR should be more or HP should be more? எப்ப delta H negative, delta H negative சொன்னா delta H negative, it's exothermic. Positive endothermic. எப்ப இது நெகட்டிவா வரும்? When it will be more, when the heat content of the which one is should be more for exothermic? Equation பாருங்க. சொல்லு.
Reactant, sir.
Very good. When the heat content of the reactant is more than the heat content of the product, then it would be exothermic. If it is endothermic, the product should be more heat content
Yes,
in the reactant. Okay. Is it clear? So what is exothermic reaction? In the chemical reaction which accomplished with the evolution of heat is called exothermic. The chemical reaction which are accompanied, okay, with the absorption of heat. So evolution of heat or absorption of heat. இது வந்து evolution of heat or release of heat. This one absorption of heat. Okay, that's all about exothermic and endothermic. One more point I would like to add, and then we complete this first law. Tomorrow we will have the heat law, Hess law, bond energy, spontaneity, entropy, Gibbs free energy, and end of the thermodynamics. Okay. Under Wednesday we can have the calculation part, all the calculation. So now we from this point we come to one conclusion that each and every reactant which has it has their own heat capacity, right? So one of the reactant, because it has their own bonds, different bonds இருக்கிறதுனால heat capacity different இருக்கும். So what is heat capacity அப்படின்ற ஒரு question rise out. So heat capacity is the amount of energy needed to raise the temperature of a specific substance by 1 degree Celsius is known as its capacity. So heat capacity is equal to quantity of the heat divided by temperature rises. So the heat capacity is the ratio of amount of heat transferred to an object and the resultant temperature rise. That's equal to heat capacity. What is heat capacity? The amount of energy needed to raise a temperature of a specific substance by 1 degree Celsius is heat capacity, or otherwise the ratio of amount of energy transferred to the object by the resultant temperature rise is known as heat capacity. So the unit of heat capacity is the joules per degree Celsius. Okay. Molar heat capacity அப்படின்னா அர்த்தம் 1 molar of the substance, 1 mole of the substance. If you are raising 1 degree of the temperature, then it is called molar heat capacity. Specific heat capacity அப்படின்னா என்ன அர்த்தம்? So 1 gram of any substance, okay, if you are rising 1 degree is known as specific heat capacity. Okay, so the unit for the molar heat capacity is joules per mole per degree Celsius, or otherwise Kelvin. For specific heat capacity is joule per gram per degree Celsius. So the quantity of heat that become Q is equal to delta T C into M. What is delta T? Change in the temperature. C is the specific heat. M is the mass of substance. It gives the quantity of heat. This is how we can derive, so we can have the quantity of the heat. புரிஞ்சா heat capacity ஒவ்வொரு சப்ஸ்டன்ஸ்க்கு ஒரு heat capacity இருக்கும். When you are raising the temperature, that gives ஸோ உங்களை மேக்ஸ் கிளாஸ் இருக்கு இல்லையா? யாராவது இருக்கீங்களா உள்ள?
Yes, sir. Yes, sir.
பாதி பேர் ஓடி போயிட்டாங்க சொல்லதுக்குள்ளாம. ஓகே, யூ கேன் கோ அண்ட் ஜாயின் த மேக்ஸ் கிளாஸ்.
Thank you, sir.
Thank you, sir.
தேங்க்யூ.
Yes, sir.
ம் ம் ம்